My name is Christopher Hong. I often hear that students who are struggling with high school math tend to approach math as an exercise of memorizing various formulas. Many students don't realize how different areas of math are actually related to one another. Today I'll be talking about DeMoivre's formula as a way to illustrate how different areas are connected. So DeMoivre's formula is basically a connection between trigonometric functions and complex numbers. So this is DeMoivre's formula. It's cosine of theta plus I sine of theta to the power of n equals cosine of n theta plus I sine of n theta. Alright, so what does this really mean? So first I'm going to talk about the polar form of a complex number. So polar form of a complex number is just r times cosine of theta plus I sine of theta. So this is the polar form of a complex number. It's actually really similar to the polar form of a normal xy coordinate. So this is actually just equal to r cosine of theta plus I r sine theta. And the normal polar form of a normal xy coordinate is just x is equal to r cosine theta and y is equal to r sine theta. So this is basically the same thing, but it's just x plus I y, which is just the normal form of a complex number. Yeah, so x would be the x coordinate and y would be the y coordinate, which would be the imaginary part of the complex number. So if we were to graph this, it would just be the same as the graph of a normal xy coordinate, the normal xy coordinate. So, but instead of with the x and y axis, we use the real and the imaginary axis. So if we were to take an example, I plus 3i, the real part of this number would be 5, and the imaginary part of this number would be 3. So it would be, here it would be 5 plus 3i. So if we were to take the polar form of an imaginary number, it would just be the same as the polar form of a normal xy coordinate. So we would take the angle, this would be theta, and the radius would be r. So let's practice taking the polar form of complex numbers. So let's take the polar form of 1 plus I. And this is, and if we wanted to do this, we would basically just use the same method as we would when taking the polar form of a normal xy coordinate. So this on the xy plane would be 1, 1. So 1 would be the x coordinate and 1 would be the y coordinate. So if we wanted to take the polar form of this, it would be the same, basically just the same as taking the polar form of this. So if we were to take the polar form of this, we use these formulas, and as well as tangent of theta is equal to y over x. So we can find r and theta just using these formulas. So if we were to use this formula, we say tangent of theta is equal to 1 over 1, which equals 1, and so we would find that theta is equal to pi over 4. And if we wanted to find r, we would just use one of these formulas. So we would just say r1 equals r cosine of pi over 4. Cosine of pi over 4 is root 2 over 2, so 1 equals r times root 2 over 2. And so r would be root 2. So we found the polar form, we can find the polar form of 1 plus I using r and theta. So it would just be, as we shown here, this is the polar form of a complex number. Root 2 times cosine of pi over 4 plus I sine of pi over 4. Alright, so now we know how to take the polar form of a complex number. So how does it relate back to DeMoivre's formula? So the left side of this formula, cosine of theta plus I sine of theta, that's basically just just the polar form of a complex number with radius 1. So it's basically just any complex number with a radius of 1. So what does that look like? Well, that's just basically the unit circle. Since this is the set of all points with radius 1 from the origin. So yeah, so the left side of this formula is just any point along this circle, so any complex number with the radius of 1 taken to the n power. Alright, so what DeMoivre's formula says is that the power of any number along this unit circle will stay on this unit circle, since the right side of this equation is also the polar form of a complex number with radius 1, since it's cosine of an angle plus I sine of an angle, which is basically the same thing as this with radius 1. So DeMoivre's formula says that if you take the power of any number along this circle, you'll also get a number along this circle. And furthermore, it states that the answer you get will be just the power you take it to times the angle. So for example, we take a very basic example. If I wanted to take the power of I, and the polar form of I is just, since I is right here, and the angle of this, and the angle of I would be pi, would be 90 degrees or pi over 2. So this would just be cosine of pi over 2 plus I sine of pi. So if we wanted to take I to the power of 2, using DeMoivre's formula, we would just multiply 2 times pi over 2, the angle. So this would be equal to cosine of pi over 2 times 2 plus I sine of pi over 2 times 2. And this would be equal to cosine of pi plus I sine of pi. And this is negative 1, since the angle, since this angle pi would take us over here to the negative 1. So, and if we wanted to take I to the third power, we would just multiply the angle by 3. So it would be 1, 2, 3 to negative I. And if we want to take I to the power of 4, we would just multiply the angle by 4. So 1, 2, 3, 4. And we get back to 1. So this sort of explains the cyclical nature of the powers of I. So now we're going to go through an example of how to use this DeMoivre's formula to be able to calculate the powers of complex number a lot easier. So let's take the power of 1 plus I to the power of 4. We already took the polar form of this number. It was root 2 times cosine of pi over 4 plus I sine of pi over 4. Now we can see that this can't exactly fit into DeMoivre's formula since we have a radius of the square root of 2. Well, we can actually get around this pretty easily. So since we can just distribute the power, so this would be root 2 to the power of 4 times cosine of pi over 4 plus I sine of pi over 4 to the 4th. So yeah, so we can just distribute the power like this. And now we can, this part, the left side part of this is easy. This is just 4. On the right side of this, you can just use DeMoivre's formula to multiply 4 times pi over 4. So this would be this cosine of pi over 4 times 4 plus I 4. And this would just be equal to 4 cosine of pi plus I sine of pi. This would be equal to 4 times -1, which is -4. So using DeMoivre's formula, we were able to make this. We were able to take this power pretty easily just using these trigonometric functions. Now, if we were to do this without DeMoivre's formula, we would basically just multiply this out a bunch of times like this. And that wouldn't be very fun, right? So using DeMoivre's formula, we were able to simplify this exponent a lot easier using trigonometry. Yeah, so I'm gonna show you another example of using DeMoivre's formula to solve the power of a complex number using trigonometry. So let's take √3 plus I to the power of 9. So this is another example where the radius of this number is obviously not 1. So how do we find the polar form of this number? So we can actually take a little shortcut. If we graph this out, so the x-coordinate is √3, and the y-coordinate is I, 1I. So this is the point, √3 plus I. So we can actually just draw a little right triangle here. And this side would be 1, and this side would be √3. And so we can use the Pythagorean theorem to find the hypotenuse. So this would be 2. And this is actually a special right triangle. So we know that this angle is actually just 30 degrees, or pi over 6. So we know that the angle would be pi over 6, and the radius is 2. So this would just be 2 cosine of pi over 6 plus I sine of pi over 6. This would be the power of 9. So now we can do the same thing we did in the last problem to be able to solve this relatively easy. So this would be equal to, we just distribute the power, 2 to the 9 times cosine of pi over 6 plus I sine of pi over 6 to the 9th. And so the left side, you can use a calculator. It's 512 times, and the right side, you would just multiply 9 times pi over 6. So this would be times cosine of pi over 6 times 9 plus I sine of pi over 6 times 9. And this is equal to 512 times cosine of 3 pi over 2 plus I sine of 3 pi over 2. And cosine of 3 pi over 2 plus I sine of 3 pi over 2 is just a place on the unit circle where the angle is 3 pi over 2, so it would be down here. And this is just negative I. So this is equal to 512 times negative I, which is equal to negative 512I. So again, we were able to take this pretty complicated exponent, and using the DeMoivre's formula, we could just use the angle of the polar form in order to find the answer. And we only did it in like 5 steps. Yeah, so using the DeMoivre's formula, we were able to take the powers of complex numbers really easily, just using trigonometry. So thanks for watching.